Theory of operation. How does an ultrasonic Doppler flow meter work? Let's give credit to Christian Johann Doppler, a 19th century Austrian physicist known for his paper on the Doppler effect. Let's update his analogy to perhaps something more modern. Have you ever heard a train go by recently? Remember how the pitch changed as the train raced towards and then away from you? First, the pitch became higher, then lower. This change in pitch resulted from a shift in frequency of sound wave, as illustrated in the following picture. So, as the train approaches, the sound waves are compressed towards the observer. The interval between waves diminished, which translates into an increase in frequency or pitch. As the train recedes, the sound waves are stretched relative to the observer, causing the train's pitch to decrease. By the change in pitch of the approaching train, you can determine if it's coming near or speeding away. Now, if you can measure the rate of change of pitch, you could also estimate the train's speed. Let's consider the same situation with a clamp-on ultrasonic Doppler flow meter. This technique is to clamp it on the outside of the pipe, but the process liquid does require that it has some suspended gases or solid to reflect your signal. Now, of course, the advantages of the technology that it's clamped on the outside of the pipe, there's no pressure drop and there's no obstruction to flow. The way this thing works is the Doppler meter continuously transmits high frequency sound that travels through the pipe wall and into the flowing liquid. Sound is reflected back to the sensor from the suspended solids or bubbles that are in the process liquid. If the fluid is in motion, the echoes return at an alternated frequency proportionate to flow velocity. Doppler flow meters continuously measure this frequency shift to calculate your flow. So what we've learned is an ultrasonic Doppler flow meter must have suspended solids or aeration in a process liquid for it to work. Generically speaking, it differs between the brands, but most brands require that liquids have at least 100 parts per million of suspended solids, not dissolved solids, suspended solids that are about 75 to 100 microns in size. No suspended solids or aeration, you'll get no signal. So the Doppler flow meter works best on closed full pipe applications that are either heavily aerated or with lots of solids. So for example, slurries, paper stock, raw sewage are ideal for an ultrasonic Doppler flow meter. Traditional flow meters would be, for example, in wastewater, would be sewage and sludge, and in mining applications and food applications where there's always a lot of suspended solids. Here are some generic examples of ultrasonic Doppler flow meters that comes in portable versions, heavy duty, light duty, as well as dedicated wall-mounted units for monitoring process controls and inventory. As you can see from our application guide, Doppler flow meters work best in dirty liquid, slurry applications. They're available as portable, wall-mounted, and for weatherproof enclosures. At Instruments Direct, if you have any other questions about theory of operation about ultrasonic Doppler flow meters or any other flow meters or level control devices, don't hesitate to contact us by email, our toll-free number, or log on to our live chat. Thank you for attending.